Let's look at this interesting example based on basic proportionality theorem. So we have been given ABCD is a quadrilateral. PQ, R and S are the points of trisection of the sides AB, BC, CD and DA respectively. We have to prove that PQRS is a parallelogram. Now, we want to prove PQRS is a parallelogram, then I have to prove that PQ is parallel to RS. Also I have to prove PS is parallel to RQ. So let's write down first what we need to prove. What we have to prove? We have to prove, since we don't have any information about the lengths so that we can say parallelogram opposite lengths are equal, we will go ahead with opposite sides should be parallel. That is what we want to prove. That seems to be easy because basic proportionality theorem will allow us to prove that. So we will say to prove PQ parallel to RS and PS parallel to RQ. This is what I have to prove. Now, what is given to us? Given to us that ABCD is a quadrilateral. PQRS are the points of trisection of the sides AB. What is the meaning of points of trisection? They divide in the ratio of 1:2. It's actually 1:2 or 2:1, but we see here that it is in the form of 1:2. So what is the meaning of that? The meaning of that is AS by SD is 1:2, CR by RD is 1:2, CQ by QB is 1:2 and AP by PB equal to 1:2. Let's write it down. So what we know by the meaning of points of trisection is, we know that AB is divided in the ratio of 1:2. So AP by PB is equal to AS by SD is equal to CQ by QB is equal to CR by RD is equal to 1/2. This is what we have been given. Okay. Now, if I know AP by PB equal to CQ by QB, I can say that AC is parallel to PQ. But I don't have AC. See, we can apply the basic proportionality theorem only when I have a triangle and I have two sides of a triangle in the same ratio. Then I can say that the line joining is parallel to the third side. So let me draw AC now so that we can get triangles here. I'll just join AC. Okay. Now let's consider this. Let us see, in triangle ABC we have AP by PB, AP by PB is equal to CQ by QB. If AP by PB equal to CQ by QB, or you can say BP by PA equal to BQ by QC, then you know that PQ is parallel to AC. So that tells me that PQ is parallel to AC. Now let's consider the other triangle. So we got now PQ parallel to AC. We will go ahead and try to prove that SR is also parallel to AC. Then we can say PQ is parallel to SR. So we'll take consider the triangle now ADC. We'll say in triangle ADC, AS by SD is equal to CR by RD. We know that is equal to 1/2. Therefore, I can go ahead and say that AC is parallel to SR, or I can say SR is parallel to AC. From these two, I get PQ is parallel to SR. Now, let's do the same thing for the other two triangles. Okay, now we are able to prove that PQ is parallel to SR. Now only the thing left out is I have to prove PS parallel to RQ. For that what we will do? We will consider the next two triangles. So for that I have to prove PS parallel to BD. I have to join BD first. Then I will prove PS parallel to BD and also PS and BD parallel to RQ. Then I can say PS parallel to RQ, because we know AS by SD is equal to AP by PB equal to 1 by 2. So we can leverage that. So let's do that now. Now we have joined B and D. We have joined B and D. So we want to prove now PS parallel to RQ. So first point will be to prove PS is parallel to BD, then RQ is parallel to BD, which tells me that PS is parallel to RQ. Now tell me which triangle I have to consider to prove PS parallel to BD. I have to take the triangle ABD. We will write down in triangle ABD we have AP by PB is equal to AS by SD, which is equal to 1 by 2. That means we know that PS is parallel to BD. Similarly, we consider the other triangle. In triangle, we'll consider the triangle CBD. In triangle CBD, we know that CQ by QB, CQ by QB is equal to CR by RD. That is also equal to 1 by 2. So we know that by basic proportionality theorem QR is parallel to BD. Now from these two equations we get PS is parallel to QR. PS is parallel to QR. So once we know that PQ is parallel to RS and PS is parallel to QR, then we know that it's a parallelogram, because in a parallelogram two pairs of sides are parallel to each other. So let's try to summarize this. We have been given ABCD is a quadrilateral, PQRS are the points of trisection of the sides AB, BC, CD, DA respectively. We have to prove that PQRS is a parallelogram. So let's first try to understand what we have been given. We have been given that AP by PB equal to AS by SD equal to CQ by QB equal to CR by RD equal to 1 by 2. That is what we have been given. Actually we can take it as 1:2 or 2:1. Only if you take it 2:1, that parallelogram will be a little bit big in size. 1:2 will be small in size. Nothing much difference. Okay. So now we see that the corresponding sides of the triangles are in proportion, but we don't see the triangles there. We have a quadrilateral. So we try to divide this into two triangles, joining AC first. Then we divided ABCD into two triangles, ABC and ADC. Then we can apply on ABC and ADC basic proportionality theorem. That will give us that if I take triangle ABC and ADC, I get that PQ is parallel to AC and SR is parallel to AC. That tells me PQ is parallel to SR. Similarly, if I join BD, then I'll have triangles ABD and BCD. I will have PS parallel to BD and RQ parallel to BD, by which I will get PS is parallel to QR. Since we have PQ parallel to RS and PS parallel to RQ or QR, we have a parallelogram. PQRS is a parallelogram. So in the next session we'll try to solve one more interesting example related to triangles, basic proportionality theorem or similar triangle concepts. Thanks for your time and support. Bye for now.